Okay, so let's look at question 4a on practice test 1. So it says solve the initial value problem. So we're given this differential equation here with the initial condition y of pi over 4 equals 0. So let's move this term here with the dy dx across. So doing that we get then. So we get this then. And now let's multiply both sides by dx. So doing that we get this. And now you should realize that this is separable. It means we can get all the x's and dx's on one side and all the y's and dy's on the other. So let's divide both sides by e and also divide both sides by cosine of 2x. So doing that we get then. So we get this separating. So you got cosine over sine. So that can be written as a cotangent, this guy, and this e to the y at the bottom can be brought to the top and written as e to the minus y and multiplied in. So doing that and simplifying we get then. So we get this. Again, the e to the y here brought up as e to the minus y multiplied in. So it'd be e to 2y minus y, so it'd be just e to the y there, and it'll be minus y, e to the minus y, which I have here. And I wrote the cosine over sine as cotangent. Now let's integrate both sides. So integrating both sides we get then. So integrating both sides we get this. I'm going to break this integral on this side up into two pieces, because this part here is going to require integration by parts. This one we can do directly. So breaking this up into two integrals we get then. So we end up like that. We end up with this. So recall the integral of cotangent is going to be the ln. Well, actually, we're going to make a u substitution here. So making a u substitution here. Say let u equal 2x. Actually, I'm going to call it w. I'll explain why in a second. So w equals 2x then for this guy here. So dw dx will be 2, so dx then will be dw over 2. So let's rewrite this guy over here then. So doing that we get, so we get this then. So the dw over 2 in place of dx here, I pull the 1/2 out in front, so it's going to be then integral of cotangent of w here, dw, and the integral of e to the y is just going to be e to the y here. This guy we're still going to have to use integration of parts on. Okay, and the integral of cotangent is going to be natural log of the absolute value of w. So let me write it here. Okay, so we'll have then 1/2 ln of absolute value of sine of w equals e to the y minus integral y e to negative y dy. Okay, so I'm out of space here. So let me erase a few things and we'll continue. So summarizing, we have this then, where the w is 2x. It's 2x there. So substituting the w with 2x here, we got this guy here. So we still have to work out this guy here, which is going to require integration of parts. So let's do that next. Okay, so here's my integration of parts formula down here, and this is the guy we're trying to integrate up here. So I'm going to let u equal y and dv equal e to the minus y dy. Okay, so we've got u equals y, dv equals e to the minus y dy. So let's take derivative on both sides with respect to y for this guy. Doing that we get then, we get du dy equals 1, so then du equals dy. And let's integrate both sides here to find v. So doing that we get v equals integral of e to the minus y dy. And when you integrate, I guess you could do like a w substitution, already used u up here, call that w or something, but I'll let you check. It's going to be just negative e to the minus y is our answer. to be negative e to the minus y, because if you took derivative of this, you can check it's going to be e to the minus y. Okay, so let's make the substitutions up here now. So in place of u, I'm going to put y. In place of v, I'm going to put negative e to the minus y. So let's do that. Okay, so again, in place of u, I'm putting y. In place of v, I'm putting negative e to the minus y. So therefore, u times v is this. Then minus integral of v, so minus e to minus y, times du, which is equal to dy. These two minus signs will cancel, and we already integrated e to the minus y, it's this. So let me write my answer here. It's going to be negative y e to the minus y minus e to the y. So this guy here now will go in place of this up here. Notice there's a minus sign up front here, so it's going to make this both of these positive. So let me make the substitution up here. So doing that, we get then. So I just noticed there should be a minus on this guy right here. Okay, so making a substitution into this guy, so minus in front is going to make both of those positive. So it'll be this, and we'll say plus c at the end for our answer here. Okay, so now let me see. Let me erase this integration apart stuff, and we'll continue. Okay, so now recall that our initial condition is that y of pi over 4 equals 0. That means the x is pi over 4 and the y is 0. So let's plug into our solution up here. Our general solution as plug in pi over 4 for x and 0 for y. So doing that, we get then. Okay, so again, I put pi over 4 in place of x here, so it's going to be then sine of pi over 2. Then 0 in place of all the y's over here, so it'll be e to the 0, 0, e to the 0 plus e to the 0 plus c. Now sine of pi over 2 is 1, so let me rewrite this, and e to the 0 is 1. So let me rewrite what we have here. So we get then, 1 half ln of 1 equals 2 plus c. Now the ln of 1 is 0. Okay, so we get then, so the ln of 1 is 0, so you have then 0 equals 2 plus c, so c is minus 2. Okay, so let's write our final answer. Okay, so here's my final answer here. So the c is minus 2. Okay, so just put a minus 2 in place of c up there, in place of c up here. Okay, so this answer is defined implicitly. So, and that there's no way, well, it's going to be very difficult to try and solve for y, so I'm going to leave the answer implicitly like this. This is fine. Okay, so we're done with the question. So let's leave the video here. So we're done.